Good morning. Do you able to see my presentation?
Yes, sir.
Okay, thank you. Let us start. So before we proceed, do you have any question from the previous classes? Okay, then let us start. So on the last class, on the last week, basically, we discussed the parser. We mentioned one parsing table, and with the help of the parsing table, we parsed some string or sequence of tokens that we demonstrated. But on the last week, I mentioned that let us assume there exists one parsing table. The parsing table we will construct later. So today is the time we will start constructing the parsing table. So let us start with the simple one, that is LR0 parsing table. So LR0. So what is the meaning of this LR0? You know this by this time. So first L indicates that the parsing will be left to right, and this R indicates that it will be bottom up, rightmost derivation first in reverse, and this 0 indicates there is no look ahead symbol. So when it is 0 in the look ahead, then definitely you will understand that this 0 may be changed later, maybe with 1, 2, something. That will be my look ahead symbol. And yes, you are right. In general, we can write that there is LRK grammar where the K starts from 0 and it assumes some integer number, indicates that during the parsing process, how many look ahead information is available. It is true, probably you understand that if the number of look ahead increases, then probably it will be a very strong one. But we will see that k equals to 1 is enough for our purpose. But before going for k equals to 1, let us start with LR0 and see how far we can go with this one. And when we will see the restriction or limitation of LR0, then we will move to k when k equals to 1. Now you remember from the first class that this part on the left hand side, top left hand side, is your grammar. As I mentioned on the last class that when I say grammar, I will mention only the production rules. Now from the production rules, using the convention of the grammar that we mentioned, you can identify who are the terminals and who are the non-terminals. So that way you will get the set of terminal symbols and set of non-terminal symbols. By default, we will assume, unless otherwise specified, that first production rule indicates the start symbol, or the left hand side non-terminal of the first production rule is my start step. That completes the definition of the grammar. Now this particular grammar G6, we are naming it to differentiate with other grammars we have used. We are augmenting this grammar, say G6 prime, with an addition of one extra production rule. We are giving the number as 0, where we are defining a new start state S prime, which derives to the start state of the grammar, that is S. Okay, that way we are making it augmented. Next we defined LR0 items, and LR0 item is a production in G with the dot at some position on the right hand side of the production rule. So for this particular cases, if I pick the second production rule, then you see how many possibilities are there. So if I write here S derives L, my second production rule. So in one situation, dot can be possible at the very beginning of everything. That is my one item. Next, dot can be possible after the opening parenthesis or left parenthesis. That is my second item. Next, dot is right after L, but before the closing or right parenthesis, and another one will be after everything, after the closing parenthesis. So corresponding to the second production rule, so many different items are possible. Now this dot actually indicates that when I am parsing one string or series of tokens, then at which position I am. Dot indicates my current position. Okay, so one example is given here for the second production rule. I believe for other production rule also you can identify what will be the items. Now there is a closure property for the items. It says add all items arising from the productions from the non-terminal after the period in an item. Closure is computed transitively. Now if you look at the first example, then S derives to dot within parenthesis L, that is my second production rule, and the dot is placed just the beginning, at the beginning position. Now right after this dot, since there is opening or left parenthesis which is considered as the terminal, so no new item will be added to this particular item as per the closure rule. But when I am considering my production S derives opening parenthesis, then my dot L closing parenthesis, now you see the position of the dot is here. Then since the dot is on the left hand side of one non-terminal, which is my L, so everything which is part of the item of L will be added transitively as part of this item. That's why you see at this position, closure of S derives within parenthesis L, but the dot is at this position, right on the left hand side of L. So first item is the same one. Next, because the dot is on the left hand side of L, so I am adding all the items corresponding to L derives. So the third production rule will be added. So L derives dot S, dot is in front of S. Again, since dot is on the left hand side of S, so all the production rules starting with S as the left hand side, here production rule 1 will also be added, and you see it is added here. Now I didn't complete inclusion of the production rule L derives dot S. This is one production rule and this is another production rule. So there are two production rules for which L derives to some terminal or non-terminal or union of them. So both are included. L derives dot S L derives dot L comma S, that is the fourth production rule. And since at this position dot S is there, which means the dot is on the left hand side of S, so transitively S derives dot X is also added here. Next, second production rule will also be added, S derives dot within parenthesis L. Up to this, do you have any question? This is very important because the states will be computed based upon this. Okay, it's pretty simple also. Just you need to follow the dot. If dot is on the left hand side of any non-terminal, then all the non-terminals which has a production rule will also be added as part of this. And since dot was on the left hand side of that L, so on the right hand side dot S dot L comma S will be added. That way, corresponding to closure of S derives within parenthesis L, where dot is just left of L, assumes 1, 2, 3, 4, 5. 5 number of items. Okay. Now, to define a state, it is a collection of LR0 items and their closures. So from here, you can understand that this will be part of one state and this whole, all the items will be part of another state. So in the state transition diagram, starting from the production rule, now you know that what will be the states. Then you need to add the transition and you are done for constructing the table. I will show you that. Okay. Now the operation, there are 4 operations. We have seen on the last week also: shift, reduce, accept, reject. And for non-terminal, one specific operation is there, that is go to. Okay. So this is written here, you can go through this, but I would like to directly go for the example. This is an intuitive LR parser construction. So first you look at the grammar. It's a simplest grammar. Only one terminal A, one non-terminal as well as the start state, that is capital S, one single production rule, that is S derives A, is given. Okay. Now when this is your production rule, then you know how many different items are possible. So dot A and S derives A dot. These two are items only, right? Now I am drawing the parsing table. You look at this bottom right side drawing first. What will be the components in your parsing table? First column is the state number or state ID. Second onwards, corresponding to each terminal, there will be one column. Next, as I mentioned, that universally we will assume that each string is ended with a dollar symbol. Although dollar may not be explicitly written in the production rule, but universally we will assume that each token stream or string is ended with a dollar symbol. So that corresponding to that dollar, there will be another column. and corresponding to each non-terminal there will be columns. So first you will have one column for state. Next you will have all the terminal symbols, and corresponding to each terminal symbols you will have one column. Usually this is the order using what the parsing table is drawn. You can think that, okay, so I can say swap between the columns, that is fine, but generally this is the standard. After the terminal, again one special column will come, that is the dollar symbol indicating the end of the string. Next we will start empty or non-terminal symbols. Incidentally, for this simple one, I have only one terminal, that is A. Dollar is general assumption, and only one non-terminal S. So there are three columns corresponding to terminal, non-terminal, and dollar, and first column is for state. Okay? Any question here? Good. Now I augmented this grammar by having one extra production rule like what I did last time. Now I am defining one new start state is prime, which derives to S. Along with that one, actual production rule S derives to A is there. And if I assume this is my 0th production rule, then it will be my first production rule. Sometimes you may see that because of this augmentation, here after the S, optionally some people write dollar to conclude everything. Okay? Now let us start with the state diagram. Since I have two production rules, so first corresponding to this production rule is prime. So I have one item dot S, right? Now you know by closure property, since dot is on the left hand side of S, so all the production rules will also be included as part of this. And since dot was on the left hand side of A, so dot will be on the left hand side of A. That is my 0th state here. You see two items are there. S prime derives to dot S, S derives to dot A, what I mentioned. That is my 0th state. Okay. Now from here you see that dot, my current position for the parsing, is there. Two possibilities may occur standing at position 0. Either I can see terminal A, then I will move on to state 2, or I see non-terminal S, then I will move on to state 1. Two possibilities are there. Corresponding to each possibility, there is one state, state 1 and state 2. If I see dot S, then if I see S, then I will go from 0th state to 1 state. If I see terminal A, then I will move from 0 to state 2. Since I have seen S, so when I will move from state 0 to state 1, then the dot will move from left hand side of S to the right hand side of S. That you probably noted here. So this dot you can able to locate. Okay. Now when I will see A, then I will move from S derives dot A to S derives A dot. So now dot is on the right hand side of A. That's it. Now you see that from state 1 or state 2, I have nowhere to go. The dot has reached at the end, indicating that as per the production rule, I have finished the traversal. Okay. Once you have drawn this state diagram, then it is the time to draw the parsing table. So first thing, what I will suggest you to do, that corresponding to each state, you will make an entry as row. So state 0, state 1, state 2. Okay. Now from state 0, if I see dot A, then what will be my action? Then I will shift this pointer from A left hand side of dot to the right hand side of dot and move on to state 2. So shift to state 2, shift and go to state 2. That is my action. Okay. Now standing at 0th state, if I see S, then what will be my action? Go to state 1, that is here. Right? Now standing at state 1, if I see dollar, now you look at the production rule 0. In the 0th production rule, I say that augmentation is required because I am appending $1. Dollar indicates the end of the string. If it is so, then this S prime derives to S dot indicates that after the dot there is a dollar symbol, right? There is $1 symbol. If it is so, then standing at state 1, if I see dollar, then I am supposed to make a transition, but that transition leads to my accept state. So that is my ACC. So standing at state 1, if I see that my next character is dollar, then that leads to accept state. Okay. Now standing at position 2, if I see one more A possibly, or if I see dollar, then I will go for the reduction. And reduction by which production rule? Production rule 1. That's why R1, R1. Okay. Now except these entries, all the blank indicates that there is a parsing error as per this grammar rule G3. So standing at position 1, if I see there is one more A, then I have nowhere to go. Then I have nowhere to go. That is my parsing error. Standing at 0th position, if I see immediately there is a dollar, that also leads to blank. So error state. Standing at 1, if I see one more S, since there is only one production rule, so I have nothing to nowhere to go. So that is error. And this is also error. So all the spaces indicates that there is an error state. Sometimes it is possible to look at those blank and then identify what kind of error it may leads to. Accordingly, when say you will be designing the parser, then you may say write some error message. Some of you asked me that during the assignment 2 whether we need to report only the error or what kind of error it is. So I mentioned for the time being it's just an error is enough. But when you will do parsing, you see that you will have an idea by looking at these blanks what kind of error it may lead. So you can print accordingly. Now you see that similarity with the C compilation process. During the C compilation process also, C compiler used to give you some message. So right now I am not in a position to tell you that all the errors are coming from the syntax or through parsing, and you will also accept that one. Some error may come from the logic or somewhere else later. But when there is an error during the parsing process, as you got from the blank spaces, then this blank will be error, and in this location, instead of blank, what you can have, say one particular error message, so that when you will be in that particular, so I can consider this as a matrix cell, so you will be in that particular matrix cell, then you just trigger that error message that this is the error. So that will give some guidance. Now let us make a little complex or G4 where we have two production rules instead of one. I believe items are very much clear to you right now. So explicitly I am not going to write down the items. Again, for this particular grammar, I am augmenting this by S prime derives S, and you understand that $1 is there at the end of this S. That's why, or that is one of the main purpose for having this augmented grammar or one extra production rule. Now the state 0 or the first state will start with this production rule. This is my P0, production rule 0. This is my P2 and P1 and P2. So the first one is my P1, second one is my P2. You see that there is a vertical line indicating that OR. So two production rules are combined and written there. Now I will start with state 0 where the item is S prime derives dot S. Since it is on the left hand side of the dot S, so both the production rules where S derives will also be part of this state, and that way second and third one has come. In both the cases you see that dot is on the left hand side of A and B respectively. Now if this is my state 0, then how many different possibilities are there for transition? One, of course, when I see S, then I am going to state 1, and then it is S prime derives to S dot, and you understand from the previous experience that I have reached to the accept state. No more transition is required from this position. Okay. Now standing at state 0, if I see A, then I will shift the dot from left hand side of A to the right hand side of A, and my item will be S derives, and my item will be here S derives A dot S. Now you see dot is on the left hand side of the non-terminal S. That's why both the production rules which involves derivation of S is also available, and S derives dot AS, S derives dot BC. That is following the closure rule of the item, and also this is my second state. Now from state 0, if I see B, then again I will shift the dot from left hand side of B to the right hand side of B, and I will reach to state 3. Now from state 2, if I see dot, if I see S, then I will go from state 2 to state 5, and you see that S derives A S dot. Since dot has reached to the end, then I have nothing there. Okay. Now, if I see A, then I will have S derives A dot S, which is nothing but the second state. That's why there is a self loop. Okay. And if I see that B, then B dot C, initially I may think that it will go to some new state, but I see that, okay, this is the state 3. So I am marching to state 3, B dot C. Now from third state, if I see that C is there, then dot will move from left hand side of C to right hand side of C, and I will line to state 4. Okay, so these are the possibilities. Now you see, apart from these, no other transitions are possible corresponding to the grammar G4. Okay, if it is, then I can construct the parser table again. Now, as I mentioned, that first column is my state ID. Next, terminal symbols. How many terminals are there? From the grammar, I will see A, B, and C. So A, B, C. Next, dollar, end of the string. Next, only non-terminal, that is S. But you understand that for the augmented grammar, S prime is the start state as well as the new non-terminal. But corresponding to that, I am not having any column. The reason is very simple. When I will reach to state 1, then I will reduce by this production rule, in this case 0, production rule 0, and I will accept that. Okay. Now, how many states are there? 0, 1, 2, 3, 4, 5. So I will write 0, 1, 2, 3, 4. Oh, one more will come. I missed that. 5 will come. Okay. Now, from the 0th state, if I see A, where shall I go? I will make a shift and will go to second. So that's why S2. From 0th state, if I see B, then I will go to S3. From 0, if I see S, non-terminal, then I will go to state 1. Sometimes this is also written as G1, indicating go to 1. Sometimes it is written without G. Now, standing at 0, if I see C, then as per this production rule, there is no action which says that I cannot realize that string using this parser table or parsing table following the grammar. So this grammar actually do not accept that particular string. Okay. Now, if it is the first state, state 1, only one action is there. Only when I will see dollar, I will accept that state. No other action is allowed. Standing at state 2, you see how many outgoing edges are there. 3 outgoing edges are there. When I see A, then it is shift to 2. So when I see A, so it is shift S2. When I see B, shift to S3. When I see S, then it is go to 5. This is my go to 5. Similarly for 3, so I will see that when I see C, then I will shift to S4. Now comes regarding state 4. When I am at state 4, whatever will be the terminal symbol on the right hand side, but since I got BC and this is my handle, so I will reduce. And reduce by which production rule? Reduce by production rule, S derives BC, that is my P2. So that's why for all the terminal symbols including dollar, I will reduce it by R2. Production rule 2, reduce by production rule 2. When I am at state 5, then I will reduce. I got AS on the right hand side, which I can realize. So I will reduce by production rule P1. That's why R1 for all the terminal symbols. Okay. Now here some examples are given. S derives BC dollar, S derives A capital S dollar, and then ABC dollar. So examples are given. You can work out with these examples. Any question up to this? Okay. It seems very simple, and indeed it is. Now here is one parsing construction that G4 S derives A capital S or PS, the previous one, this production rule. The table, we know that what is the table, parsing table, and we are interested to parse AAA BC dollar. Initially the state is 0, that is the stack top symbol, stack top state. Input is AAA BC dollar. When I see A looking at staying at state 0, so let me erase. Staying at state 0, when I see A, then shift to second. So 2 is here. I am shifting A. Again I see A as the input standing at state 2. Again it is telling shift 2. So 2 is further 2 is pushed. One more A is read. Then I see A again. Then it will shift A. Okay. So further I will push A. I will shift A and I will push to 2. So there is a small typo. Please note it down. There will not be S here. So okay. So just up to this one. 3 A's has already been realized or read. And stack state is 0, 222. Now standing at state 2, when I see B, standing at state 2, when I see B, then it says shift 3, S3. So shift B here and push third state here. Standing at state 3, when I see C, standing at state 3, when I see C, shift S4. So I am shifting C here and I am pushing 4 here. Now standing at state 4, when I see that input is dollar, standing at state 4, when I see input is dollar, reduce by R2. What is my R2? S derives BC, second one, because this is my 0, this is my 0, this is my 1. First one is 1 and second one is 2. Reduce by R2. So S derives BC. So you derive by this, S derives BC. So this BC. And after the reduction, you know what to do. So 2 terminals has been removed. So that's why 2 states will be popped out, 3 and 4. Then my stack top state is 2. So I am standing at state 2. And I see that because of the reduction BC to S, S is remaining as the non-terminal symbol. So standing at second state here, when I see S, then go to 5. I have to go to 5. So 5 means 5 will be pushed here. Now after pushing 5, I see that input is dollar. So input is dollar, reduced by R1. So AS will be reduced to S. So AS, these two, this AS underline will be reduced to S, and since one terminal and one non-terminal will be reduced from the symbol, so 5 and 2 will be reduced. So stack top is second state, and I see that because of the reduction, symbol is S, stack top 2 and symbol is S, again go to 5, so this 5 will be pushed. Again the same production rule will be used for reducing AS, and 5 and 2 will be reduced. Since 2 is on the stack top, after AS reduced to S, then go to 5, again I will push 5 and 5 and S, further reduction, and this 2 will be popped. Since this is reduced to S, so my state is 1 and I see dollar. So 1 and I see dollar, so my accepted situation. Okay, now on the last column, I am not sure whether you can able to see this properly or not. So the parsing tree is being constructed. So because of this reduction, so BC, sorry, let me draw from the bottom. So BC is constructed, and that is derived to S. So following this one, next following AS, so this S is already there, so add one more S, you will get this one, then another AS, so A and this S, you will get another one, then AS, so A S, that way you will go, and 3A BC, 1 2 3A and BC, that is your parsing table. Okay, any question from here? Okay, now here is another example. The grammar rule has changed. Augmentation is already been done. S prime derives to S derives to X, S derives to within parenthesis L, S derives to S derives to L comma S, and corresponding to that the state diagram is drawn here, and this is my parsing table. So here the first state instead of 0 is marked as 1, that's why, so this first column, this is my state number. Okay, so this state number first column is basically starts with 1, goes up to 9. I'm not going through this example, I think it is easy. So whatever we have discussed, based upon that one, you can able to figure it out. If you have any question, so on the next class you raise that one, we will definitely discuss. Here, as I mentioned, in some cases G is mentioned as go to, so here you see G, but sometimes G is also not mentioned for the non-terminal, but you know what will be the action if it is non-terminal. And if it is terminal, since there are two possibilities, shift and reduce, then mandatorily you have to mention whether it is S or A. Otherwise, if I say use only 3, 2, 1, then I'll be confused whether it's a shift operation or it is a reduction operation. But for non-terminal, it is always the go-to statement. That's why G is optional. You may write or you may not write. Okay. And for this parsing table, so one string is also given, input string within parentheses X comma X. So it will be realizing that one. So again, I am not going through this. You please go through this. If you have any question, so you please tell me on the next class. Definitely we will discuss. Here is another grammar given to you, G7, and for this I do not have any parsing table. So it is your practice example. For this, you please draw the parsing table. Okay. Now, when we are constructing this one, we demonstrated nicely that how to construct the parsing table. Now, if the grammar is like this, say G5 grammar, S derives AS or S derives A. In this particular case, the way we have discussed the construction of the parsing table, we can start by introducing one new start state S prime and augment the grammar S prime S. Now you just look at the production rule. So this SLR1 parser you need not have to look at now. Now this is my zeroth of start state. S prime derives dot S derives dot AS, S derives dot A, because this second and third is coming based upon the closure property. Now if I see S, then I will move from 0 state to 1 state and I will realize we have seen that one. If I see A, then I will move on to the state 2, and this second production rule or second item actually here will be written as S derives A dot S. Now, since dot is now on the left hand side of S at the first item of second state here, so by closure property, other options will be included. What are the other options? S derives dot AS and S derives dot A. So these two actually has come as part of the closure property of the first item. Now if you look at state 0, the third item here, this item will also, along with the second item, will also move on to state 2 if I see or if I realize A, and that I am writing here with a color red, say, right? Now from state 2, if I see S, then I will move on to state 3 for item number first or first item in state 2 for first item here. From here I will move on to state 3 when I see S. Now when I see A, then the confusion will arise. What is the confusion? For state 2, you look at the item second and third. Both says that if I see A, then I will shift and dot will be placed on the right hand side of A. Correct? But the last or fourth production rule at state 2, which is also colored as red, it suggests when I see A, then I can reduce the previous A to S using the second production rule. S derives to A. Right? Now the situation is at state 2 in the parsing table. If I see A, then item 2 and item 3 suggest you self loop and shift. So S2 it suggests. But the fourth production rule at state 2 colored with A indicates you reduce to S using the second production rule R2. Clearly, there is a shift reduce conflict. So this situation, the same grammar actually from the previous slide. So we have a shift reduced conflict at this position. So because of these three production rules. second and third of state 2 indicates you go for a shift, and fourth indicates you go for a reduction. So how to decide on which one to take, or whether to reduce or to shift? In order to handle that one, we have to use some extra information. So this is another grammar where these three production rules are there. Now you consider two items. So E derives T dot plus E, another E derives T dot. So for the first production rule, if item is just if the dot is just before addition, and in the second production rule, if the dot is just after T. Now you see, in both the cases, so I am at state 3. So starting from first state, upon looking at T non-terminal, I have reached to state 3. And here you look at the two items. For one, I will suggest you shift when I see addition, and for another, I will suggest reduction. But you know, as of now, I do not have any look ahead information. I am at this dot position. I cannot see the next character, that is my look ahead. I do not have that one. And as of now, whatever I have read and the knowledge I gathered, based upon that one also, I cannot make any decision whether to reduce or whether to shift. That's why in the parsing table at state 3, for looking at addition, I have a confusion whether to reduce or to shift. In order to deal with this problem, in SLR parser, what it is suggest that only modification is done at the blue line. It suggests reduction by production only on the input symbol that belongs to the follow of the left hand side. So if it is as part of the follow, then you reduce, otherwise you will not. That's why for that particular grammar, and when this is my parsing table, my confusion is at state 3. Upon looking at addition, I will take a decision based upon my follow information. So we discussed the first and follow definition. So if K belongs to follow S and K is part of the terminal which occurs on the right hand side of any production rule, then you go for reduction, otherwise shift operation. And following that one, the suggestion is from state 3, you go for the shift operation, not for the reduction operation. Okay. Up to this, do you have any question? Okay. Then let us stop here today. So what we studied today, starting from constructing the LR0 parsing table, we see that for some grammar, we can successfully realize some string. But some conflict at the whether to shift or reduce may occur sometimes. For that situation, we need not have to resolve that one using LR0. One solution we provided today by looking at the follow information. On the next class, we will look for some look ahead information and we will modify LR0 to LR1 or LALR something that we will discuss on the next class. Okay. So thank you. Let us stop here today.